In this lesson we're going to look at something called correlation. Now if you look back at the maths and science scatter graph, you should see that there is a connection between the science and the maths marks. If we have a person here getting a high science mark, then they're also getting a high maths mark. Same's happening with this person, this person, this person. As you decrease, then the science mark's decreasing and so is the maths mark. So 40 and 50. And look what happens when there's a poor science mark of say 10. There's also a poor maths mark of 20. So we can say that these two things are connected. As the science mark is getting better, then so is the maths mark. As the science mark's getting poorer, then the maths mark's getting poorer, and we call this thing correlation. So you should notice there's a fairly strong connection between the grades. We say there's a strong correlation between the data set, and it usually forms this kind of line that's going up like that. The line can also go down the way as well, and we'll have a look at that. So correlation is basically a relationship between two variables. It can be strong and it can be weak. If it's a strong correlation, then when you draw a line through the dots, they're all very close to that line. And when it's going up like this would be called a positive correlation. Okay, when they're going down like this, that's not a positive correlation anymore. Instead, that would be called a negative correlation. Now you can see here it's a weak correlation because all the dots are not close to the line. However, it's still following a sort of downward line here, but not as strong as the first one. And this one here, there's no correlation at all because the dots are all over the place. They don't form a line going down or going up. So what do we think about these things? Would they have a relationship between daily rainfall and daily sunshine if I was to plot this in a graph? Well, if you think about daily rainfall, the more there is rainfall, then the less sunshine there is. And the more sunshine there is, the less rainfall there is. So there would be a connection between the two there. There would be correlation. The letter in the first name and the letter in the second name, there's no relationship between that. That's a very random thing, letters in your name. Pocket money and age, well, as your age increases, then usually it tends to happen your pocket money goes up because you need more and you're a bit older. So there would be a relationship there. And distance travelled in a train and number of station stops, well, as the distance travelled in the train increases, generally the number of stops increases too. You used to have more chance and opportunity to stop, so that would have a correlation. Now, when you have a correlation, we like you to try to draw the line of best fit in. This is a line going through the dots that you saw back here, these lines. Now, the line of best fit has rules. We have to do certain things. The rules are that you need to cross as many points as possible, and you need to split the group up roughly so the same amount are above and below the line. Now if I look at the line on the board, or the scatter diagram here, I'm going to show you a line of best fit that would be good and bad and so on. So you can see roughly they're kind of going up like this, roughly in that direction. Now if I drew the line over here, then all the dots are towards this side, okay? None are on this side, so that's not a very good line of best fit. The same idea here, we've got none on this side but loads on that side. And what you're trying to do is get an even number either side. Now that doesn't mean that you split them like that. Okay, you have to follow the general direction of the dots, and you can see they kind of tend to go up that way. So 1, 2, 3, 4, 1, 2, 3, that's about right, I would say. Now this is open to your own judgment. When you do this kind of thing in a test, there is leeway, okay? It's not an exact line of best fit we look for, but it's roughly right. And we'll extend this back so as it cuts this axis as well. So I would say that's pretty good. Line of best fit crosses as many as we can, and there's the same number of dots below as above. Okay, we'll just look at these diagrams here and see if we can draw lines of best fit in. Now again here I would say it would go up like that. Is that about right? 1, 2, 3, 4. Yep, that's very good. This one I wouldn't say there was any correlation, the dots seem to be all over the place. This one here looks kind of down the way, but it's kind of weak. But I'll try and draw it in round about there, and then I'll adjust it if I need to. 1, 2, 3, 4 that side, 1, 2, 3, 4 that side. I think that's pretty good. This one here, we've got a kind of crisscross shape going up here and over here and down, so that's no correlation at all. This one kind of going down like that. Again, I'll just double check. I've got 1, 2, 3, 4 there, 1, 2, 3. Maybe just slightly adjust it. Not much. Maybe down a wee bit. Let me see, that's a bit right. And the last one is kind of going up like this, isn't it? And I'll just check the same number of dots either side as best I can anyway. 1, 2, 3, 4, 1, 2, 3, 4, 5. Maybe just put it over here a wee bit. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5-ish. That's about right, I would say.